Hello all, my name is Krish Naik and welcome to my YouTube channel. So guys, Google is again on bang and it has created its own open source LLM model that is called as Gemma. Now again, it is on that specific race of open source LLM models also. Till now, the most accurate model that we specifically had was from Meta, that is called as Llama 2. Now Gemma is there. In this specific video, we'll try to see a practical application. Along with that, we'll try to fine tune with the help of this specific Gamma model. Okay. So what exactly is Gamma model? I'll just show you one blog. First of all, why they have actually created it. At the end of the day, all the companies, is saying this thing, right? So Gemma is built for responsible AI development from the same research and technology used to create Gemini models. Okay. At Google, we believe in making AI helpful for everyone. We have a long history of contributing to open source communities such as Transformer, TensorFlow, BERT, T5JAX, AlphaFold, and AlphaCode. Obviously, Google is doing, I think it is from past so many years, it is doing so much of research, specifically in open source contribution. It has given TensorFlow, it has given many things as such. Along with that, Meta is also in the same race. Both are doing fabulous job. So let's go ahead and let's know more about Gamma. Gemma. We'll say Gemma. Okay. Gemma also we could say. I don't know how to pronounce it, but it's fine. So if I probably talk about this, the main thing that you really need to know is about the performance metrics. Over here, when I compare, see, two models are there with respect to this particular model. One is 7 billion parameter, one is 2 billion parameter. If I consider with respect to Llama 2, we have 13 billion and 7 billion. With respect to all these things, I think Gamma is performing absolutely fine. Here you can see that it is having 64.3 with respect to various benchmark accuracy. If you want to know more details about it, you can actually see this particular blog. Over here, if we are just comparing open source models like Gemma and Llama 2, Gamma is way forward when we compare with respect to the 7 billion parameter it has, right? 64.3, the general accuracy, reasoning is 55.1, 81.2, math 46.4. It is far better than the Llama 2 models also, right? So this looks absolutely great. Here the accuracy is also very good. Now let's see more about it. It is specifically used for research purpose. You can also use it over here. You can build your own models. And the other thing is that right now, the Gamma 2 models, right, 2 billion parameters, 7 billion parameters, already available over here, see, in Hugging Face. So once you probably go to Hugging Face and search for Gamma 7B or Gamma 2B, you'll be able to see this kind of page. Here, you need to get granted to access this model. So here, they'll tell you to probably check the terms and conditions to get the license of this particular model to use it. Okay, so it will be like a checkbox. You just need to check it. I understand that and give the confirmation, right? Once you probably do that, you will be able to get the access of this specific model. What is the main aim of this particular video? I'll try to show you with the help of practical implementation how you can access this particular model and how you can actually use it. So now let's go ahead and let's see this fine-tuning technique with the help of Google Gemma model. And again, guys, this is just a simple use case that I've taken over here, but you can do some amazing use cases with the help of this. And that is what I'll plan in the future. Some amazing use cases that I've already developed with paid OpenAI models. I'll try to also develop that with this along with fine tuning. Okay. So initially, what we are going to do, we are going to see this Google Gemma model, how it performs and what kind of task, all that kind of NLP task you'll be able to do it. Okay. So initially to go ahead with, I will go ahead and install all these libraries, that is bits and bytes, PEFT, TRL, Accelerate, datasets, and transformers. If you don't know, guys, I've already created a video with respect to fine tuning. Okay. Now in fine tuning, what we have actually done, we have done the fine tuning with the help of Llama 2 model. Okay. So let's see, a UTF local is required. Let me restart my kernel, change runtime, disconnect and delete runtime. Okay. So let me go ahead and reconnect it and then we will try to do the installation again. But I've already created a fine-tuning technique with the help of Llama 2 model. The same steps and process will basically happen over here also. So it's got connected. Now let's go ahead and do the pip install. So here you'll be able to see the pip installation will specifically happen with all these libraries. To just tell you what we are going to do, this bits and bytes techniques, bits and bytes libraries used for quantization purpose. I've already created a video with respect to quantization. What is the main aim of quantization? Quantization actually allows you let's say that you have a huge model, right? Right now we have this Google Gemma model of 7 billion parameters or 2 billion parameters. If I want to load it, let's say in Google Colab. So in Google Colab, right now I have somewhere around 50 GB RAM or 201 GB hard disk, right? And right now I'm using this Google Colab premium version, right? Let's say if you are using it, you'll hardly get 15 GB RAM. It is not possible to load that entire model over here. So what quantization techniques helps you do is that it helps you to convert that float 32-bit, right? Usually all the numbers, all the weights, right? All the bytes are saved in 32 bits. It will help you to convert that into 8-bit, 16-bit. So when you convert that, you require less memory at that point of time, right? So that process is specifically called as quantization, and I have actually explained it. I've shown you how mathematically we specifically do quantization. So everything is explained in this particular video. I'll provide you this link in the description of this particular video. Now the next thing is that we will be importing some important libraries. One is OS, transformers, then you can probably see Torch, Google Colab user data, data sets I'm going to load it, SFT trainer, PEFT, right? PEFT, PEFT, LoRA configuration. As I said that we are going to use LoRA technique, okay? SFT trainer is specifically used for fine tuning purpose, supervised fine tuning, we basically say. Right now from transformers, we are also going to use auto tokenizer, because tokenization, if you want to really perform tokenization while fine tuning, we'll be using this auto tokenizer so that it can load based on the model that we have. Then you have this auto model for casual LLM. This is specifically used so that we'll be able to fine tune with respect to casual large language model. Okay. Then from transformers, we are also going to import bits and bytes config. Here we are going to give the configuration with respect to quantization. And then we have this Gemma tokenizer. So let's go ahead and import all these things. So Gemma tokenizer is something for the Gemma model itself, right? So a tokenization technique. Otherwise, you can also use other tokenization. It is not necessary that you always need to use Gemma tokenizer. Now let me tell you one more step. The next thing is that after importing all this, you know that this Gemma 7B model is specifically present in Hugging Face, right? Now, in order to access this model, in order to download this model, we really need to have something called as access token. Access token of what? Access token of the Hugging Face. So how do you get an access token? Go over here, click on settings, and here you'll be having something called as access token. Just copy this, okay? Copy this access token, and once we have this access token access, right, then only we'll be able to download the model from here. So here, what we will do, go ahead and set it in the Google Colab. How do you set it? Click on this key button. So everybody will be having this key button, and just click on add a new secret, and I have written it over here as HF_token with that same value that I have copied from there. So once I probably write it down over here, so this is basically saved, right? So this is saved over here. Now, once I've saved it, any number of notebook that you specifically work in, you will be able to access this Hugging Face token. How do you access it? It is in simple. os.environment hf_token is equal to user data.get hf_token. You just need to write user data.get hf token. So once you do that, it will ask you for the grant. You just need to grant it, and then it will be able to access, and it will be able to also identify which Hugging Face from which username or password or which username you are specifically pulling that particular information. Okay, so this is done, right? Now through this, you will be able to access any models from the Hugging Face, right? Let it be Llama 2, any model that you specifically want to use. Now what we'll do, we will go ahead and call this particular model Google Gemma 2B. Initially, I showed you 7B, right? I'm going to load it 2B, right? 2 billion parameters, not 7B. 7B also you can do it. It'll still take time for the fine tuning purpose. Now here you can probably see I've taken this, and then I've written bytes BNB configuration, that is bits and bytes configuration. The first parameter is load in 4-bit is equal to true. That basically means what? My model, the Gemma model in 2 billion parameters is specifically in the 32-bit, right? Initially, we are trying to convert that into 4-bit, and this process is specifically called as quantization, right? So what we are doing is this, once we set it in load in 4-bit, all the activation functions, all the weights that are stored in 32-bit will get converted into 4-bit, okay? Now the second parameter that you'll be able to see, BNB_4-bit quant type is equal to NF4. What is NF4? 4-bit normal float. So the quantization technique, how do you convert this into a 4-bit, is basically taken from this particular parameter. If you really want to know about it, I've given a link over here. What is 4-bit quantization and how does it help Llama 2? The reason why I've written Llama 2, because we are talking about open source model. Then you have BNB 4-bit compute type, which is nothing but torch.bfloat 16-bit. Now, the reason we have kept this as 16-bit, see, this we are performing quantization. That basically means we are taking a big model, we are making it to a small model. How? By performing quantization, by converting the 32-bit into 4-bit. Now, along with that, whatever fine tuning takes place, for those fine tuning, all the weights that gets updated will get updated with respect to this particular 16-bit. See, there is some loss of information with respect to quantization. To balance that, we are keeping the new fine-tuned parameters in 16-bit. So that is the reason we have written it over here. So once I execute this, so this is my model ID, this is my configuration. Now, based on this model ID and configuration, I am going to use the tokenizer. And from this particular pre-trained model, I'm going to call the tokenizer. And for here also, I'll be using the HF token. Okay. Then you have model. Over here, auto model for casual LM from pre-trained. Model ID, we'll use this model ID. That, see, auto tokenizer is to call the tokenizer that is required for this particular model, right? And here also I've given the HF underscore token. Automatically that tokenizer will got called, right? Then we are using auto model for casual LM. And here also you'll be able to see that we are using model ID, quantization config with respect to the BNB configuration. The device map will be equal to 0, which is nothing for the GPU. And here you can see that I'm going to use the HF underscore token. Okay. So once I execute this, you will be able to see that I am going to download all those information. See, auto model specifically to call those particular model, the model ID that I've given over here by applying this quantization technique. And this entire process is going to happen in the GPU that my Google Colab is connected to. And over here, I've given the token. So quickly, you'll be able to see that the entire model will get downloaded. And now all the information will be specifically present in this particular model. Now, with the help of this particular model, I will go ahead and test it now. Now, see this, how I'm going to test it. I've given a quote over here, imagination is more. I've used a device CUDA is equal to 0. That basically means whatever is the GPU that is available. And then I'm going to use this same tokenizer. See, this tokenizer is basically getting used. I give the text and I get this particular information. So this input will be a vectors, right? And then what we do, we use this same model and we say dot generate with respect to this particular input. And let's say that I'm going to take a token of 20, okay, initially. Then once I get this particular output, the output will have in the form of list, like what all information is basically coming. So once we write tokenizer.decode of output 0, see, at the end of the day, we are doing sentence generation. So when we write model.generated, it is again going to create some embedding vectors, right? And that output, which is in the form of vector, will get decoded with the help of tokenizer. And then we'll get the real text. So if I execute this, you'll be able to, and it is saying skip special token. If any token is there, it will get removed. Okay. So once I execute it, you can see imagination is more than knowledge. I'm a self-taught artist born in 1985, right? So this information is basically coming based on the model that it has. Let me go ahead and execute once more. Okay. So here also you can able to see that I'm trying to execute one more time. Let's see whether I get a different output. So here you can see imagination is a more than knowledge, knowledge is limited, imagination encircles the word. So this information is given by Albert Einstein. Okay. So two information. And if you probably search in the internet, you will be able to find this quote also. Okay. So over here, one output we got where with the code completion. Here you could probably see that I'm also getting the author name. Okay. Now, this is what it is able to do it. Okay. So whatever information you probably put it over here, it will be able to get the output based on the information that you require. Now what we are going to do, I'm going to show you a fine tuning technique. Now see this. OS.environment WAN disabled. So one parameter we need to keep it as false. That was given in the documentation also. I did not still understand why this parameter was used, but once I know it, I'll let you know, because I'm going to create a lot of projects as we go ahead. Now we are going to fine tuning with the help of LoRA configuration. So for LoRA configuration, what all information I require? One is rank. Okay. So LoRA technique is something called as rank decomposition. We'll get to know. I've not still uploaded the theory video. So here we can select the rank value. Okay. So rank over here is selected as 8. Why 8? Why cannot select 16 or 64? You can select any number. But understand what exactly is rank decomposition. For that, I need to create a dedicated video, and soon I'll be coming up with this. The target modules, in this, you specifically require this KV parameters, gate up project, down project. So that these are some of the target models that is required. As I said, guys, once I probably upload a video dedicated to LoRA configuration, you'll be able to understand. The task type, we always need to keep it as causal_lm. That basically means it is specifically used for this language modeling task. So this is one of the parameter that we need to set it up. So once I execute this, now let's go ahead and do the fine tuning. Okay. So this is my LoRA configuration. Now the data set that I'm going to specifically use is this. Okay. So let's see this data set. Okay. So I'll see this arbitrate English quotes. Okay. Okay. Let me see whether we are able to find it out or not. Arbitrate hugging face. Okay, I'll just search for hugging face. Now this is the data set. If you see this data set, you have two information. One is quote, one is authors, right? Based on this information, this is the quote and this is the author. And we'll try to fine tune with this. Let's say that my Gemma models knows some of the quotes in the internet along with the author. Okay. Now my main thing is that I'll have some more additional data set and we'll train with this specific data set and we'll then identify the author for this particular quote. Okay. We'll do something like that. We'll implement something like that. So here you can see that I am loading this particular data set from arbitrate_English quotes. And then we are taking a sample from this sample of quotes. Okay. So here we are going to execute this. And if I just execute data train of quote, right? So I will be able to see all the quotes over here. Okay. Quotes, you can also see the quotes, you can see the authors and all. So this entire is getting generated, and here you can see train split is also happening. And once this is executed, here I have my data set. So if you probably go ahead and execute it, you'll be able to see all the quotes. Okay, so the quotes, the sample of quotes that we have. There is nothing noble in this. So information, as you can see. Okay, so this is my data set. Now, whenever we perform SFT, that is supervised fine tuning, right? We require some information. Okay. One function we specifically require to indicate what is my input and what is my output. Okay. So here we have used something like this quote example quote of 0. So this is my first parameter, like 0. Okay. And then whatever information is that this is my input and this will be my output. So quote of 0, author of 0. So that basically means quote of 0 indicates, I will show you it. This quote of 0 basically indicates each and every sentence over here. Author of 0 basically indicates this one. Okay. So this information will be my output and this will be my input, something like that. Okay. So once I format this, you'll be able to see that I'll be able to return my text. Okay. So let's consider over here. If I give any examples over here, right? So here you'll be able to see that any kind of examples. From that example, quote will be separated and author information will be separated. And then we return that particular text in the form of key value pairs in this list. Okay. Now is the time for SFT trainer. So here we use the model, we use the data of train. Data of train is what? So let's see this. Okay. So you'll be able to see what is exactly data of train. The same data of train you'll be able to see where I'll have all those information. This is my features, author, tag, input ID, and attention mask. Okay. Then we use some training arguments per device, batch 1, gradient accumulation steps 4, warm-up steps thing. I'm going to run it for maximum steps of 100. Learning rate is so much. FP16 is true. Then output directory will be this. Optimization will be this, right? PEFT config will be nothing but my LoRA configuration, and whatever formatting function I'm using, I'll be using it over here. So same formatting function. Okay. So that I get the text in this particular key value pairs. So once I execute it, you'll be able to see it. So here you have your training will probably start now. Okay. Once I write trainer.train, and we are going to run this for 100 steps. Now see how fast it is going to happen. The reason is that 2 billion and we are trying to convert that into 4 bits. I think the training will quickly happen and we are taking just a sample of data. Okay. Sample of data. So here you can see 26 steps is done. 100 steps. And here you can also see that loss is decreasing, right? 0.39, 0.39, 0.2180, 2080. It's good. 0.131. So loss is keep on decreasing over here. Okay. Now this quote you will be able to see I've taken from one of the over here. Let's see. So here, so a human is like a tea bag and then my author should be Eleanor Roosevelt, right? So now once we execute this, I think we should be able to get that specific response. Okay. From that particular model. So let's say 89, 91, 92, 100. It is reducing it is increasing a bit, but again, it is in that step. So training output, global step. If you still want to reduce the loss, what you can basically do, you can increase the number of steps. Now here I have a quote, a human is like a tea bag, CUDA is equal to 0, tokenizer this, model.generate this, same thing. Now let's go ahead and execute it. I should be able to get the author name in forward. See, Eleanor is coming. A human is like a tea bag. You can't tell how strong she is until you put her in hot water. Okay. So that information you can see, you can never know how strong it is until you put it in its hot water. So see, all this information is basically coming, and the author is also coming as Eleanor, right? So let's see this. I will also take one more example, something like this. Let's see whether we will be able to generate the same thing or not based on the data set that we have, because we have already doing the fine tuning. Okay. So I will something like this. Okay. Now let's execute and see the output. And again, now every fine tuning you can specifically do it this specific way, right? I've just shown you in one example. The opposite of love is not hate, it's fear, and the opposite of fear is freedom, and the most wasted of all days. Let's see whether it is there or not. See, the opposite of love is not, opposite of love is not, it's indifference. The opposite of art, faith, is not, somewhat, it's almost equivalent, right? Fear, opposite of freedom, most of the wanted is. Okay, let's try some more. Okay. Oh, this looks unique. Unless and until this person is not a famous. The book is man's. So I will just go ahead and execute this. Let's see whether we'll be. And again, understand guys, we have just max new tokens as 20 because it needs to also complete this entire statement. So outside of a box, dog, a book is a man's best friend. See? Man's best friend, author is Nicholas Comfort. The quote is again the most wasted days of all days in one. So you can probably see over here, right? Inside of a dog, something. All the information is great, right? So you can check it out with different examples. But again, at the end of the day, yes, fine tuning is good in this. Again, as we keep on doing more and more, we'll be able to do it. Now, all the application that we have specifically created, like text to SQL, invoice, we'll try to do it with the help of this itself. We'll also try to do the fine tuning. Let's see how things will come up. But I hope you like this particular video. This was it from my side. I'll see you all in the next video. Have a great day. Thank you and all. Take care. Bye-bye.